In this video, we're going to look at some examples of tables of quadratic functions, and by the end of this video, you should be able to identify quadratic functions given a table, as well as describing the rate of change for a quadratic function given a table. For each table below, describe the rate of change, identify the type of function represented that could be linear, absolute value, quadratic, or none of these, and explain why you picked the function that you did. So looking at our first one, find the change in x's and find the change in y's. You should see here that change in x's were all +1. Your change in y's are all different. And so that means we have all distinct rates of change. They're not constant at all. So that means we should look at second differences because you can also see that there's a turning point. So you can see right here, I go from decreasing to increasing, and that I point to what would be a turning point or a vertex in my graph. When it has a vertex, it can be either absolute value or quadratic, but we know it's not absolute value because you can see that these are not the same. With absolute value, you have two constant sections. You have a decreasing constant section and an increasing with a constant rate of change, and I don't have that. So that's why we're going to look at our second difference. And so that means we're going to look at these right here. It can be helpful to use the number line, especially when we're going from positive to negative. So I have -3 to -1 is going to the right 2. So that's increasing by 2. From 1 to so from -1 to 1 is also going to the right. So that's increasing by 2 and so on. You can see that I'm increasing by 2 all the way down my table. When my second difference is constant, and you can label that if you want, that's what we're finding here. This is called a second difference. When my second difference is constant, we say that the rate of change is increasing by 2. So the rate of change is not constant, but it's increasing by a constant amount of 2. And when we see that, we know that we have a quadratic function. And the reason we know that is because there is a turning point and the second difference is constant. And you can abbreviate that a little bit. For number 2, do the change in x and change in y all the way down your table. And as you've noticed, since we're doing second difference a lot of times, it really helps to keep your changes organized. So when you're doing the change in y, and you're going from -26 to -12, that's between those two values, and to kind of write it between those values and not be sloppy the way you write it. So again, you can see that we have various changes in y, and we have a constant change in x. You see that we start to have patterns here where we have some repeated values, and we can also see right away that we have a turning point right here because it goes from increasing to decreasing, and that where that changes is where you see the turning point or the vertex. You can also see that because that y value doesn't buddy up, it doesn't have a partner it's paired with. So you see here these y's, there's 2 4s, there's 2 -2s, there's 2 points that have negative, leaving this 2 6 to be the vertex. So now let's take a look at our second differences. So when you're going from 14 to 10, so 14 is over here on our number line, to 10, you are going to the left 4, so that's a -4. And then from 10 going to 6 is also going to the left 4. From 6 to 2 is decreasing by 4, and then from 2 to -2 is also going to the left or decreasing by 4. And you can complete this down your number line to see that we are continuing to decrease by 4. This shows us that our second difference is constant. So it also tells us that our rate of change is decreasing by 4. It's not decreasing by -4, it's decreasing by 4. The decreasing is the negative part. And because our second difference is constant, we have a turning point, second difference is constant, that tells us that this is a quadratic function for those reasons I just said. So because there is a turning point, or you could say vertex, has a vertex, and the second difference is constant. For question 3, find the change in x and change in y. So you can see that your change in x's are constant of 1, and your change in y's are also constant of -10. So here we can say that our rate of change is constant, -10 over 1. And what does a constant rate of change tell us? That this is a linear function. And the reason it is because we have a constant rate of change. To summarize our big idea so far, to recognize that linear functions have to have a constant rate of change, like you saw over here in question 3. Absolute value functions, we didn't have in these 3 examples, but you could have them in this assignment. They're always going to have a turning point. You will notice some repeated y values, but the rate of change, there's just 2 different rates of change and they're opposite. Whereas a quadratic function still has that turning point or vertex and some repeated y values, it does not have a constant rate of change. And so you have to look at second differences. If those are constant, then you know that it's quadratic. So you're looking for a rate of change that's increasing or decreasing by the same amount.